Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamotho. And in this video, I want us to learn something about the graphs of sine, cosine, and tangent. And we'll be doing this from Pure Mathematics 1, topic number 6, and on page 123 and 124. So we are talking about the graph of sine, cosine, and tangent of theta. And there are some fundamental things that we need to know before we even know how to construct this graph. Number one, the graph of sine, cosine, and tangent are periodic. That means they repeat themselves after a certain interval period. So what about if we just took one graph, y is equals to sine theta? This graph, it repeats itself every 360 degrees and it crosses the x-axis at theta being equals to negative 180 degrees, 0, 180 degrees, 360, moving forward. So you can see after every 180 degrees, it crosses the x-axis. It has a maximum value of 1 and a minimum value of negative 1. And this is just a sketch of the graph y is equals to sine theta, and you realize that even if you took your calculator, the sign of negative, let's talk about the sign of negative 180 degrees is simply equals to 0, and that is why we've plotted 0 there. And the sign of negative 90 is negative 1. The sign of 0 is 0. The sign of 90 we know is 1. And then it crosses the x-axis at 180. It crosses the x-axis at 360. Then plus 185.40. But of course it has to have that kind of flow. Note that the maximum value is 1 and the minimum value is negative 1. You can see the graph repeats itself after every 360 degrees. For instance, it was 0. It was giving us the value of y being 0 at theta being equals to 0, moving up, and it is also at the same kind of value of y, which is 0, again moving up. So from 0 to 360, it's one period that the graph repeats itself. And we would wish now to talk about the graph of y is equals to cosine theta. Again, it repeats itself every 360 degrees and it crosses the x-axis at negative 90, 90 degrees, 270 and 450 moving forward. It has a maximum of 1 and a minimum of negative 1. And if we may wish to just have a rough idea of what this means, and this minus 90, this is minus 180 degrees, and this is of course 1, and this is negative 1, this is 0, we have 90 there, we have 180 there, 270, 360, we have 360 plus 90, we have 450, and we have even 540 degrees. Of course, to start with, it crosses the x-axis at negative 90, at 90, at 270, and of course at 450, moving forward. So what about the cosine of negative 180 degrees? If you talk about the cosine of negative 180 degrees equals to negative 1. It's just equals to negative 1. And there we are. So if this graph is allowed to have a normal flow, it's going to behave like, simply going to behave like this. So this is the graph of y is equals to, this is the graph of y is equals to cosine theta. And there we are. That is just the graph of y is equals to cosine theta. And I would want us now to go to the graph of y is equals to the tangent of theta. And this one is a bit special graph because well, the graph of y is equals to tan theta, it repeats itself every 180 degrees. We must say that it repeats itself every 180 degrees and crosses the x-axis and crosses the x-axis at negative 180, 0, 180 degrees, 360, moving forward. This is something that you must listen to, that it has no maximum or minimum value. It has no maximum or minimum value. It has no maximum or minimum value. This one is another piece of information that is quite critical for this. It has vertical asymptotes. It has vertical asymptotes. It has vertical asymptotes. I know you know what asymptotes are. At x is equals to negative 90 degrees. X is equals to 90 degrees. And of course, you add 180 to this one, and x is equals to 270 degrees moving forward. And therefore, the tangent of theta does not have maximum or minimum points, but approaches negative or positive infinity. It has to be known that the fact that it doesn't have a maximum or a minimum, it approaches negative infinity and positive infinity. That one has to be understood by all. As the curve approaches the asymptote, of course, we will see tan theta is undefined along the asymptote. It is undefined along the asymptote. And let's just sketch the graph of y is equals to tan x. So allow us to have something like this. This is 0. Of course, let's start by the tangent of 0 is itself 0. We are already told that there's an asymptote at negative 90. This is an asymptote. There's an asymptote there. There is another asymptote at y is equals to 90 degrees. This is another asymptote. There is another asymptote at 90, 180, 270. There is another asymptote at 270. This is 270 degrees. And we are simply going to see how this works. What is an asymptote? An asymptote is a line that is never touched by the graph. And I want us to just work out what happens when theta approaches negative 90 to the left. First of all, let's talk about theta being equals to negative 45. So the tan of negative 45 is going to become, this is going to be 1, and this is going to be negative 1. So we have negative 1 there. And as theta approaches negative 90, let's talk about negative 89. What is the tan of negative 89 degrees? It's negative 57.3. Negative 57 is so much down here that it is not possible to show it in this graph. But even as we approach negative 90 further, the tan of negative 89.9, let's see what that is. Negative 572.9, that is already a negative infinity. So this graph talks of behaving like this. Of course, we know the tan of 45 is 1. What about the tan of 89.9? As now theta approaches, what is the tan of 89.9 degrees? It's positive 572. It's such a big number that it becomes an asymptote. But let's talk about 91 degrees, just when it crosses over this line. What is the tan of 90.1 degrees? Again, negative 572. So again, very far away to the negative side. So you can already see, you can already see that this one is coming far away from an asymptote. What about the tan of 180 degrees? Again, this is 180 and 0 and 270. So we have a graph that looks like that. And we have a graph that again looks like that. And I'm very sure this is 360 degrees because the tan of 360 degrees is again equals to 0. And there we are. So this is, in a nutshell, the graph of y is equals to the tangent of x, because from here you should add 180 degrees, 270 plus 180 degrees, and the other asymptote is at 450. So you can imagine our graph looks like that. This is 450 degrees. Yes, so this is now the graph of y is equals to the tangent of theta, and that is simply how it looks like. Please make sure you understand the sketching of the graphs. The graph of sine looking like that, the graph of cosine looking like that, and the graph of the tangent looking like that. Again, visit my YouTube channel, subscribe and share widely, and let us use this graph in the next video in solving trigonometric questions. All right.